This is Unit 14, Video 1. In this unit, we'll talk about two types of compounds, two classes of compounds called acids and bases. Extremely important in chemistry. You don't want to leave chemistry class without knowing about these. So let's get to it. We'll study acids first. And the thing to say is that we're going to begin with the properties of acids, and then we'll talk about some reactions and so forth. So first of all, acids by definition produce H+. H+ technically is a little proton. This is a proton because hydrogen by itself only has one proton because the atomic number is 1. There are no neutrons. So when you lose an electron, become positive, you just get a proton. And protons are what acids produce, and that's why acids are dangerous, you can say, because they produce free-flowing protons that can run around and do some damage. Now, the major properties of acids are that they taste sour. A very famous acid is found in lemon. Lemon has what's called citric acid and many other citrus fruits. So they are also electrolytes. Remember, electrolytes means they conduct electricity in water. In order for this to happen, you have to have ions in water for them to conduct electricity. And since acids produce ions, they are electrolytes. Now, acids feel like water. This is a physical property, but if you take a look, so when you try to pour acid on yourself or on your hands, which we do not recommend, but if you were, and for example, if you were to feel what a weak acid looks like or feels like, it would feel like water. You wouldn't be able to distinguish it from water. And acids also react with metals. What you see here on the picture on the right, this little ribbon is magnesium ribbon. And magnesium ribbon reacts with acid to give hydrogen gas. So those little bubbles that you see are hydrogen gas being produced. So when acids react with metals, they produce hydrogen gas. Now the hydrogen gas actually comes from the H+, which the acid makes. So the H+ is actually converted into elemental hydrogen, is the idea. Now, in acid, the H+ that's produced by acids, or in water, we should say, the H+ is actually converted to H3O+, this substance here. This is called the hydronium ion, and here is the reaction that's usually given. H2O plus H+ gives you H3O+. Now, the reason for this is because the hydrogen ion is very unstable. It's very tiny, and being tiny, it's very unstable, so it will team up, you can say, with a water molecule to produce this hydronium ion, H3O+. And that's really how it exists in solution. So in solution, you'll never have free-flowing hydrogen ions in an acid. You'll have these hydronium ions. Let's keep going with the properties of acids. Acids also turn the properties of acids, or first of all, acids always begin with H in our case, because H, hydrogen, is the active portion of the acid. Now there's a famous litmus test, which involves a piece of paper called litmus paper. And in an acid, litmus paper turns red. This is something that usually people know about. It's called the litmus test. So here is an acid in this solution. And notice this litmus paper, this is the litmus paper, is being dipped into the acid, and it comes out red, which means you have an acid. You can do this little test with fruits, with vegetables, really with any chemical, to determine if it's an acid, because many chemicals are indeed acids. It also turns another indicator called phenolphthalein clear. Now this indicator you'll see we'll use is added to the acid. So in this case, this is a solid like a piece of paper you dip in, but phenolphthalein is actually a liquid that's added to the acid, and it turns it clear. Both of these are indicators. There's a lot of indicators with acids and bases. Let's go through some famous acids. We're going to just roll quickly through 6 of these slides. The first and most famous one, most likely the one that you have used many times now, is hydrochloric acid, HCl. This is the acid found in your stomach. And this is actually what helps kill the germs in the food that you eat. In a way, helps digest your food as well. It's known on the street as muriatic acid. It's been known in this way for many, many years. This is a common name, muriatic acid, and it actually can be purchased by this name, muriatic acid, at local hardware stores, but we do not recommend it. The second acid that you have seen us use is sulfuric acid. This is the acid that we poured on the sock, if you remember, at the beginning of the year to make holes in the sock. Sulfuric acid is H2SO4. Now this is based on the sulfate anion, SO4 2-. And this is the acid found in car batteries. Anytime there is a car accident, you have to be careful, because if a car battery gets damaged, some of the acid can spill out. There's pretty bad acid in there. And this is actually more dangerous than hydrochloric. It's also used extremely widely in industry. A lot of syntheses, chemical synthesis, uses sulfuric acid. If you take organic chem, we will use sulfuric acid. It is an extremely important acid in chemistry. The next is nitric acid. Nitric acid is HNO3, having the nitrate anion. This is NO3-. Remember, nitrate. And it's also used in industry, used in making explosives, which is pretty important for our defense industry. Rubbers, plastics, and on. We do use it in chemistry. We do have nitric acid. We use it much more rarely, but it is used, apologize, on occasion, nitric acid. Now, let's keep going. And this is, the next one is phosphoric acid, based on the phosphate anion. This is PO4 3-, phosphate. Now, this one is actually a weak acid. And it's, in fact, used as a flavoring in soft drinks. If you ever take a look at the back of a soft drink, you'll see probably that it'll list phosphoric acid as one of the ingredients. It also lists some other acids sometimes, but phosphoric acid used as a flavoring and a preservative, flavoring/preservative in soft drinks. Phosphoric acid for you. How about carbonic acid? Carbonic acid is also found in soft drinks, and it is, in fact, what gives soft drinks, like Pepsi, the bite that you feel when you drink it, especially when it's fresh. And it comes from CO2, carbon dioxide that's dissolved in the soda. If the soda is flat, there is no more carbonic acid in it. In fact, this carbonate is CO3 2-, and it got there from CO2. When CO2 is dissolved, there's a reaction actually where CO2 is mixed with water. So if you take water and you add CO2 to it, what you'll get, if you put these two together, is H2CO3. And this is what carbonic acid is. So it's also extremely important in our bodies. It's found in our blood, and it acts what's called a buffer. And a buffer keeps the pH steady. We're going to talk about pH in the next few lessons, but pH steady. It does not allow pH to change. That's the idea. That's what a buffer does. So carbonic acid, and lastly, acetic acid. This is another weak acid. These last three have been weak. This one is based on the acetate anion, acetate, that we've learned about, C2H3O2-. And if you put a hydrogen to it, you get yourself acetic acid, which is found in vinegar. Vinegar has the active acid, acetic acid, in it. All right? And how about this slide? This slide essentially talks about binary acids and oxyacids. First of all, let's say that there are many more acids out there that we do not mention. You have seen some of them, you will see some others, but there are thousands of them, and most of them are organic, which means they come from, you can say come from living things like plants, animals, but organic technically means it's based on carbon. It used to be, it's essentially acids that are organic in nature are based on carbon. But that's how they got there. So there are two types, we'll say. There are binary acids. Binary acids simply have hydrogen and some other nonmetal. And there are oxyacids, which have oxygen in them. That's why they're called oxyacids. but these are based on the polyatomic ions that we've studied earlier in the semester. So we will take a look at bases next time. In this case, this concludes for us the first lesson of chapter 14.